Let's see if this works. Currently riding my bike. Thank you. All right. Get this back in my. There we go. There's my Bluetooth microphone. See if you can hear me well. All right, Bluetooth. Yeah, my hearing aids. It's got a microphone on it. So there's that. They go, won't work because the blades and the thing and resistance. Can you prove to any of the blah 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 blah? It's like all of this has been done before. I don't have to prove shit on that one. You know what I mean? Hey, so I took a certain volume and then I squeezed it. How do you? By making it smaller. Is that compression? I'm pretty sure. Fairly certain about that. Maybe I'm wrong. Someone out there in the comment section, correct me. No, that is exactly how compression works. Please do go on. Yes, thank you. I figured that was the case. My limited knowledge, apparently. I need PhD level mathematical physics to be able to understand how compression works. Yeah. Anyways, or physics degrees or anything. Anyways, point is, for me, it turns into like, okay, so how is it that you're starting the dang thing? Well, a starter motor usually is a decent start. You know, lots of starts there. I shouldn't have said it that way. It's probably going to annoy people. Starting to annoy people is really starting to get on their nerves. I'm pretty sure that starts to have problems for my view count CPU, your impression numbers, because it starts making me get shadow banned like a startup usually does. Yeah, no, I'm that kind of asshole sometimes. Yeah. Anyways, the starter motor, it's like, yeah, well, basically, I mean, it's not impossible to just run like a starter motor in so many ways. It's like, how does that work? And it's like, well, yeah, that's a good question. For me, it's more about the blades that run the supercharger, turbocharger. It's like, oh, you know, they run at a certain point, you know, because they're connected via gear, but you know, that gear can then, what is a good way to put this? Effectively disconnect things to oil pressure or hydraulic fluid pressure. Yep. You know, because like the heat has gotten into the system well enough that it can now expand. And so that creates a pressure which disconnects it from the front main gear, which then is more of a planetary housing, I suppose. You know, bearing setup that then like disconnects and, oh, what do you know? How does it do that? And it's like, oh, I engaged this other gear because I wasn't connected to that one until the pressure got high enough. But then I still get a little bit from that system, but not really. You know what I mean? Like, I'm operating at no parasitic loss because it's still connected once it got pressurized and so on and so forth to the thing that's now spinning faster. It's just more of a, you know, frictional, I suppose, you go with on that one, where it's like it'll spin faster and it'll just add it to it. You know what I mean? Like there's only so much faster you can get, you know, that kind of thing. So yeah, that's its own. My dog is in my trailer. So if you hear that dog in the background, as I'm riding my bike, I have a little tiny trailer. Although those are other people's dogs in the apartment windows as I'm riding my bike. My dog has been sort of okay. We're heading towards a big old bike trail, or not bike trail, hiking trail, much further away than my normal one that's over by the Safeway that's near me, which I took him on that one earlier in the week, But I kind of wanted to try and be a little more exercisey, I guess, go a little further, and so on and so forth. But that is new, so it'll be what it is. But where am I going with this? Right, so that pressure will, feed itself into up to a point. So that's a, sort of a way to limit the amount of extra, speed on that you can get. Okay, like that's where it's like I don't want this to turn faster than, let's say, the top RPM of the central intake area is no more than a standard engine of topping out that's high performance, 7,000 RPM. So it's like, right, I don't want to go above the 7,000 mark. So it's like, right, that's gearing ratios, and then that's like, all right, so this is air and fuel, this is timing, this is effectively resistance. Resistance usually means heat, so you have to dial back air and fuel. You get the picture. It's a balancing act, as any ECU or person that knows how to run an engine will tell you. So you kind of restrict fuel and then restrict air and change the timing, a little less power, and you typically get a slower or a straight up, it's not going to go faster, that kind of thing. But then this gearing ratio means I don't want it to go above this amount because it'll try and push that heat energy into pushing it faster than it should. So I can reduce that fuel and air once heat has soaked into the system into becoming workable motion energy thanks to the axle along with extra air intake. Same thing with the exhaust as well. And so it's a fairly efficient engine system for producing a good degree of workable motion energy, sacrificing a still somewhat significant amount to electricity, formation and the atmosphere at large. So that's kind of what that is. It's probably, if I had to hazard a guess, in the 70% range to upper 70, maybe I got it really good, maybe 80% range of efficiency, even adding not only specifically just for work, it's all told energy capture for electricity, the turbine windmill thing. That's going to help us reduce back pressure and improve flow rates and reduce the engine parasitic loss, and therefore reduce the maintenance level of fuel. I get it. Phaser, I'm here. Engine loss of, needed heat to maintain its efficiency because it recirculates heat back into workable motion energy. But good design. You have to. I'm uploading it right now to my Xenon Reality YouTube video, as I made it into a video, and then I put it on my computer, and now I'm uploading it. So now I'm just riding my bike to the hiking trail. So there you go. So it's a fairly decent little design. Okay enough. Again, it's around the 70%. Getting even with the backflow, because that's still producing a reduction of resistance, to back pressure, which is energy used to do that. I'm doing energy used to do that. But like, if I introduce a resistive force, if I could not have it just be as efficient as possible with the least resistance as possible, then I, of course, have to have it at a higher RPM and higher pressures to be able to gain that kind of an advantage to improve efficiency flow. So it's really about like how and when you can do that versus if you can do that, you know. So at higher RPMs, oh yeah, no, I can now suddenly make more electricity, I guess. Not that I really kind of need it, but I suppose I can push it into the exhaust, try and create some plasma to break up some of that carbon dioxide into more carbon oxygen, because it's fairly hot still, you know. But like, then that's going to go into the rotational effect of the hydraulic fluid, because that heat will then be absorbed into hydraulic fluid into workable motion kind of stuff, but also keep it pressurized as it tries to go towards its inevitable conclusion towards the turbine. So, there you go, right? Now, granted, it's not like it's got the maximal amount of heat that, or electricity, really. In fact, it's fairly small amounts. So kind of feel like I'm barking up the wrong tree when it comes down to like producing a degree and measurable effect of plasma, although there might be a way to get it done in a more efficient capacity. There's a way to use some sort of electromagnetic or charge field. Maybe more specifically to me, the blades in the stator could have a spark gap generator that has a then I need a rip off, you know what I mean? Like I need to create like electricity and then like a super ground state that effectively tries to rip electrons off. So that I can overexcite and makes it much easier to rip it off, like a standard transformer design. But then it's like standard transformer designs kind of suck, and they suffer from one major flaw for me when it comes down to like, oh, I'm not improving my efficiency by utilizing a oscillatory or excitatory vibratory kind of thing, by having the electrons jump excitedly from their orbital states in a very consistent wave pattern that spikes it where we want it to be, that then jumps that and tunnels it into a ground area where it wants to go to and won't go back in to the system, which is something I'm pretty sure we can accomplish. It's not really probably as easy as I expect. And so that, and let's see here. I suppose I can use, because usually they are like extra extreme amounts of field differences, and that's how we'll get it. And it's like, that's kind of not really playing to your strengths. You give it a little bit more duration of time to do its job, and interactional equivalencies by making those oscillatory spike wave patterns trying to occur, by trying to push a consistent wave pattern through this excited gas, then it's very likely to the trailing edge ripped off as the ground state is there to receive this extra electron that otherwise normally would not have had, which is a bigger accomplishment for the given rotation that is obviously there. Work energy happens to already have on the table. So that's kind of what I feel like could be a better way of getting it done. It's like, okay, so I need to essentially make a slight reflectivity chamber on the blades that then has a resonance frequency in certain areas for its IR emittance from the exhaust that then will allow for a significant degree of excitability through electromagnetic sources with a charge difference gaining from the initial start of where the stator vane is to the rear of the uh, capturing fan blade area that is spinning. And as a result of this, it should hopefully gain a significant degree of advantage, but then I don't think that's true. So, I'm trying to use passive energy to help the process along, and I'm like pretty certain I can get further along if I figure out a way in that area to more or less uh, charge it up, so to speak, by creating a measurable degree for a split second of increase of charge, meaning more electrons than it should, like electrodes, and then able to break it off with those more electrodes, making it a little easier with a degree of those IR reflectors, and uh, as it spins, it changes its angle and resonance frequency, and as it flows, meaning it's can start where it starts, its forward position, and then it will continuously heat and try and overexcite and rip off an electron in its rear position by adding that heat back in, sort of with electricity, trying to keep it maintained, kind of like it's insulated in its own way, but really slivering it, kind of like a laser. And then that can, maybe with the pressure that's being exerted and the flow that's there, help a little bit with a little bit of the electromagnetic oscillatory effect that we're going to have to create, meaning excitatory, which is a bit different than your standard electromagnetic repulsive. We need the charge field because it now has a charge, and then we need the repulse field because it now has a measurable degree of increased electromagnetic reactance thanks to the extra electrons. And so during that period of time, I give it a little bit longer duration. If I can get it to vortex a little, or spend some time imparting some of its pressured energy into the rotation and spin inertia of the captured energy through the turbine blades. But during that time, I am, of course, going to be spending electricity energy to excite into some sort of near plasma-like state that then allows for the next area behind it to then further excite, most likely into, even though it's colder gas, it should have less electrons, so they'll want to try and react, a little bit more because we're going to rip them off at the charge field, but because it's ripping off at the trailing edge, it's going to accelerate. And that accelerational property with the reduction of electrons slightly is now going to be able to crash into a colder state. It'll heat it up a little bit, but really it's the now, yes, I get you, Phaser, I'm still here. Significant amount more of, let's see here. I'm going with, right. So it's cooling it off, but it's accelerating it as a result of that. And I'm capturing the energy whilst I'm accelerating it, changing it to a near plasma, make it easier for the next one, kind of like a plasma seed or near plasma seed, which makes it easier for it to turn into a plasma for the next side, the next set of turbine blades. But it'll be on the rear and expanding a little bit further, interacting a little longer, and it'll hit most likely that uh, more compressed spot as well. It's kind of doing a double to a point. Like it's going to accelerate faster. It's already accelerating faster in that spot, so it should make it even less dense because it's hotter too. So less pressure, so more improved efficiency for the turbine blades. I want plasma. Do I want plasma? Do we need plasma? I mean, this is a hyper-efficient design for a near plasma state. Very little energy use. You can pretty much get near plasma. A few volts, some current, somewhat decent amperage. It'll do it. It's the stator part. Oh, right, the rear part. That's what it was. Thank you. Which will still be hot and emitting more IR in a more focused direction. Which, if we do it the correct way, we can combine multiple sources of IR in a basically layered fashion with vertical strips and horizontal strips, kind of, which will allow for a interactional slowdown, but then a degree of measurable amplitude increase. So I should be able to get microwaves if I do it right, by polarizing and collapsing the IR emittance while allowing for it to be properly lensed as a laser-like effect for IR. Then I have that combined with a near cooling it, interact, then get blasted by microwave, which should then be able to be further improved upon with the interactional profile of the IR microwave emittance from charge fields. Let's see here, electromagnetics. And I'm gonna have to dump in some grounding electron spark gap surface areas for boundary layers for plasma seeding for the near plasmas, which should further excite it to full-on plasma. Then see here, it's going to expand faster because now it's got more. What do you call that? Like water has that surface tension boundary layer. Well, it's less sticky. You know what I mean? Because it's plasma. Plasma is not going to be as sticky. So it should flow faster, and we already have electromagnetics, so it should be repulsed by that, and so not add themselves in to the system of exhaust. Exhaust gets denser where that is, compresses the plasma, but also exhaust has more energy imparted once started into the plasmification of the exhaust, alongside of a significant degree of interactional profile for exothermic reactants, because it's carbon, and they want to turn it over to carbon, oxygen, nitrogen, all that stuff. And a lot of them are black electrons, so they're going to try and interact, which is exothermically going to pressurize it between two different areas, kind of like a boundary layer valve sort of system area. Then see here, it should also, when it starts flowing, create its own version of a electromagnetic field, especially since that spin will create its own version of a with the charge field open, close, and then movement vorticing. Just not sure which way it would go. Let me see here. If I can, well, no, because then there's different pressures that are on the leading edges of those blades and stators along with those fields. So it should corkscrew, which creates a, again, increase of that energy from the spin being dumped into the plasmification of exhaust, which would further allow for a longer duration of interaction for some of it and rip off some, in fact, pretty much all, I would imagine, of the carbon dioxide and carbon, or carbon, together with the oxygen and nitrogen, and it's going to combine most likely by the time it gets into the exhaust turbine turbo captured work energy area, and it would be somewhat insulated as they'd be strands or streams of plasma that are not going to be trying to impart as much heat energy back into those blades because they're going to be super flows of plasma, then they're not very Laminar-realistic. No, they'd be pretty freaking turbulent, I'd imagine. Let's see here, then you end up having a degree of that heat crash out as it has to expand, and of course, because that's a lot less easy with the engine block, turbine, and all that, then it ends up becoming a, actually, just sort of let it turn into not a plasma anymore. Try and recapture some of that energy into the exhaust energy and gain a little bit back, just a small amount, which is going to probably get back into the wind blade back pressure reducer vacuum wind blade design turbine thing, which would only be able to start doing this once enough heat and pressure have built up into the system that it can actually do this, and at the correct RPM that it would have the ability to push the resistance into it to build it up and start doing this process so it would run more efficiently the longer it's running. Once this has built up, it should also help with the flow rates, again, with the back pressure into the exhaust, and heat will be dumped back into hydraulic fluid, which will, of course, go into the intake and exhaust, respectively, increasing its efficiency and recapture into the workable motion energy that it has on tap. That's, again, longer it's running, the more efficient it becomes, but not just more efficient, it also tends to do a genuine recapture, like a Stirling engine fluidic design, but how much more, don't know. Certainly, I put it in those 90% ranges. I think on a good conservative guesstimate, like lower 90, something like that, should be a good thing. That's a fairly decent little design, you know what I mean? So it can do it. Wouldn't be that terrible, I'd imagine. It'd be a little rough, because you kind of need to spend a decent amount of fuel to get it to start doing that level of efficiency, gain that heat, and start the process, and then eventually it'll get to the point where it can maybe start to build up enough plasma and keep it going, which is still going to be like the vacuum blade design, where it's, or not vacuum windmill turbine design, where it's just a flywheel. Like it gains that efficiency, sure, and they'll keep it going for a while, but not forever at all. And I'm not going to claim it does. Yeah, and it's going to crash back into the system. Heat's going to get put in, that heat can then be used to keep itself going a little bit, gain a little bit more efficiency, so I can use a little less fuel or maintain it with the same amount of fuel, but get more horsepower and torque from that in workable motion energy. You know, it's also one of those things where it's like it only really kind of works once you start going faster, hotter, higher engine RPMs. It's not a bad thing, but then, yeah, kind of rough, to be honest, and it will slow down once you drop back down a little. I think that's kind of what I'm trying to drive at. It's certainly more efficient, but again, it's only if you're kind of cruising at those higher engine RPMs, and you're still going to be burning all that extra fuel to do it. So catch 22 kind of thing. Like, this would be just fine for like maybe a turboprop design or something. Like, you have to tend to spin at high RPMs, and you're also traveling faster because you're higher in the altitude, and it's more efficient. And so, although it's still now more efficient than a standard turbine would or turboprop ever could be. So, it's one of those, probably a good idea. Definitely should do it. Maybe not for a motorcycle, I imagine. You know what I mean? Like, motorcycle probably is a little rougher around the edges on that side to try and do. But I suppose you can do it. I mean, 7,000 RPM, we're talking like you probably maintain 7 for solid few minutes, maybe, like maybe further. Yeah, I know my dog's crying out. We're almost there, Phaser, I swear. We're further there than we are to the apartment. So, like, we'll do that. But, like, that's the basics, of what the engine can accomplish, kind of stuff. It's not going to, like, magic your way out of, like, what it is you're going to spend more fuel to gain more efficiency. And, like, you're really also having to add in to get those 90s, like, you're making that efficiency for work motion and recapture work motion also because, like, you're making that electricity and you're recapturing a little bit of that electricity, but then you're improving flow rates and recapturing some of that heat that you didn't capture in the first stage for that combustion process into improving the all right, what happened here? Is it still recording? Looks like it turned off or something. That's just what it sounded like in my hearing aids. Bluetooth microphone not detected. Okay. Well, anyways, we are, see here, going to burn more fuel. You're going to have to spend that 7,000 at RPM for a few minutes to get there. And I don't know if it really actually ever kind of be worth it, but again, that electricity energy does get recaptured fairly efficiently back into the system. It's still going to be now hotter, but now it's then also going to then be dumped out. That heat will be only slightly lost to the exhaust, which is a fairly decent way of looking at that, if you ask me. Most of it's going to get captured into the hydraulic fluid and so on and so forth, but some of it obviously will not be. And that's kind of the roughest part about the design. Give me 1 second, I gotta finish this and then I'll be back.